Hello, everyone. Good afternoon. My name is Mackenzie Martin, and my project this summer was doing an evaluation of distributed energy resource management systems for Golden Valley Electric Association. From now on, I'm going to be calling distributed energy resource management systems DERMS. If you haven't heard of those before, they are software systems that allow utilities to connect to resources on the grid edge, including shiftable and curtailable loads, distributed generation, and energy storage, and provide increased reliability, economic efficiency, and help facilitate increased renewable energy penetration through those connections by allowing flexibility on the demand side as well as the generation side. So what was the main goal of my project? Um, I wanted to understand the potential value DERMS could offer to GVA and its members. And some of my sub-goals within that were to understand what DERMS are, how they work, and what's available on the current market, learn how other utilities are using DERMS and how they started these programs, define potential use cases for DERMS at GVEA, and quantify the value of each of those use cases using historical data analysis. And then, of course, I wanted to create robust documentation so that anyone at GVA could use my findings to learn more about DERMS and their specific applications in interior Alaska and on the rail belt, and as well as supporting continuing research. So why should you care about this? Well, it's because DERMS has been able to make utilities more efficient, more reliable, and enable increased renewable energy penetration all across the country. And the same thing could be true at Golden Valley and in Alaska. There's currently no DERMS applications on the rail belt or in any of the community microgrids, as far as I know, although I'm not entirely sure on that one. And so this could be a really interesting opportunity for innovation at Golden Valley. The The methods I used to understand this problem was an initial literature review where I read published DERMS research, IEEE standards, and information distributed by vendors to get a foundational understanding of DERMS and their possible applications. And then I also met with DERMS researchers at the National Renewable Energy Laboratories to understand some of the unique challenges and opportunities of DERMS in interior Alaska and on the rail belt specifically. I then conducted semi-structured interviews with 19 GVA staff and 4 board members to understand the specific goals, constraints, and questions that people at GVA had for DERMS. And then I spoke with 7 other utilities to understand how existing DERMS systems came to be and what realistic expectations for these kind of programs are. And finally, from that, I was able to deduce 3 potential use cases for DERMS at GVA and use historical data analysis to quantify their value with 5 internal data sets and publicly available data, modeling the potential impact that a DERMS could have had in 2024 in terms of generation and cost. All right. So a couple of the key challenges I faced during this project was during my initial literature review, I found it very difficult to find reliable information on what kind of DERM systems are available today, because many of the studies I was reading were looking at forward-thinking systems that won't be available for 5 to 10 years, and much of the information coming from vendors is focused on marketing rather than informing audiences. And the way I was able to solve this problem was by speaking with other utilities that already have DERM systems, which was actually really beneficial because not only did it get that foundational understanding, but it also allowed me to pick up on some of their lessons learned and hopefully capitalize on some of that like extra nuanced information at Golden Valley in the future. And the other major challenge I faced during this project was when I was attempting to calculate the potential savings and the amount of time that DERMS would be used. That was very difficult to do without adding a bunch of additional assumptions to the model because there isn't a lot of available data on what devices that could connect to these systems are in the GVA service area or what proportion of the membership would be willing to participate in a program like this. So the way I ended up solving that problem was by creating heat maps like these. Heat maps like these, which outline the potential value available from a wide variety of systems. And one added benefit of this method over a single value estimation is that if people at GVA in the future are comparing a couple of different perspective systems, they can look at the criteria included here, which is the available megawatts of capacity reduction and the duration of sustained reduction for each of those systems and see which presents the best economic opportunity based on the different criteria offered by different vendors. Some of the other lessons I learned are if that I could start this project over again, I would really like to reorder my research process, focusing on standards and papers before diving into vendor information, just because when I was looking at that kind of stuff, I didn't have a great grasp of how to compare those vendors without that foundational understanding first. And I would also prefer to interview other utilities before talking to more GVA staff, just because a lot of the GVA staff had questions for me about what DERMS are, how they worked, the possible implications, and I wasn't really able to answer those questions at the time. So if I could make that more of a two-way information exchange as opposed to just me getting information from them, I think that would have been a really valuable change. And the other thing I would like to do differently if I could is to intentionally plan my data analysis before I start jumping in, and be able to collect more concise data and write cleaner and more code that's going to be easier to build on in the future. Just because the way it worked currently, I got a number of different data sets and I would sort of dive in immediately as soon as I got new data. And ultimately, my report ended up using 6 different data sets, which just makes it a bit of a clunkier code base than was really necessary. In conclusion, I think this was a really successful project. I was able to compile a DERMS guidebook of 4 different reports that can allow anyone at GVA to understand what DERMS are and who the major vendors offering these systems are, what a realistic DERMS integration looks like, and how different utilities across the country got started with these programs, as well as what the priorities of all Golden Valley staff are when it comes to implementing a DERMS program, and how to estimate the economic value proposed by any prospective system. I feel like I learned so much during this process. I came in with very little information about power systems or the electric grid or anything of that nature. And I really got to like talk to so many people at ACEP and GVA and different utilities and at NREL and like just learned so much more than I ever imagined. And I'm really excited that I got to put my academic interests to use in like generating new knowledge that's going to be useful and help people at Golden Valley make the best decisions for their membership. Thank you. Does anyone have any questions?
Hi, it's Michelle again. I have lots of questions today. I have 2 questions for you. One is your report for GVA publicly available? And if so, I'm going to email you, or it would be great if there is at least a redacted version if there is any private information. And B, do you want to join our beneficial electrification meeting tomorrow at 11 a.m. online and tell us all about your project and what you learned about DERMS?
So my report is not currently publicly available just because there's a lot of confidential and critical infrastructure data used in my analysis. There may be more public information coming out from GVA in the future about potential DERMS programs, but right now my results are all private for GVA staff. I would join that meeting. It sounds very interesting.
Okay, I'll send you an invite. Thank you.
Finding surprising about the different types of services and what people found from the other utilities found.
Yeah, one thing I was really surprised about is when I was doing my like initial literature review, one service that comes up a lot is like fast frequency response and volt var control. Those are things that DERMS are technically able to do, but only one of the utilities I interviewed actually utilized either of those services. That was Hawaiian Electric Company that uses fast frequency response. And I was just really surprised there isn't more of a practical application for those installations.
What kind of staff did you interview at GVA?
Everybody. I like truly everybody. I talked to people from engineering, power supply, grid modernization, electric shop, IT, cybersecurity, public relations, member services. Just like I tried to talk to as many departments as I could and get everyone's perspective so that when I was coming up with like goals, they would really represent the vision of GVA as a whole and not leave any of those perspectives out.
Hi, this is Cameron over at the Anchorage offices. You mentioned that you talked to the IT people. I was kind of curious if you're able to, what their opinions on DERMS are from like a cybersecurity standpoint.
Yeah, so because we weren't looking at any specific perspective systems, it was a very general analysis. There weren't any particular like concerns that they brought up other than um, like thinking about what network these kind of services would be on or what the telemetry protocols would be. DERMS can offer or can pose a bit of a cybersecurity risk because it introduces a bunch of additional entry points into the utility system. But the vendors in the space are very aware of that and pretty like that's a major concern of theirs and something they work very hard to do. And none of the utilities that I spoke to had any major cybersecurity concerns or scares that they were able to tell me about when I asked about that kind of.
Okay, thank you.
One more question from Anchorage office. This is Bennett. I was wondering what other utilities you talked to and kind of if they were in-state, out-of-state, and then just kind of any standout things that they were able to tell you.
Yeah, so I talked to both in-state HEA and MEA, who do not have DERMS installations at the moment, but both had looked into the subject and were able to just provide some insight about what they had found about DERMS on the rail belt. And then I spoke with Hawaii Electric Company, which was really interesting because they were the only other vertically integrated utility I could find that had thought about or implemented a DERMS system. And then I spoke with Big Rivers Electric Cooperation, North Carolina's electric cooperations, several others as well. They're blanking right now, but yeah.
Great, thank you.
Okay, so, what does this look like from a hardware point of view? Like, is a DERM something that you get and it's always associated with like a particular battery or something like that? Or can you get a DERM system and use it to control an existing load that you have, in your house?
Yeah, so actually, there's a wide variety in what's considered DERMS software. The two main categories are network DERMS, which are also called grid DERMS, grid aware DERMS, and enterprise DERMS. And then there's edge DERMS or grid edge DERMS. The main starting point for most utilities is on the edge DERMS or grid edge side, and those systems are able to connect directly with different brands of certain devices that they partner with. So through whatever API the device uses, the DERMS system is in partnership with the OEM of that device and able to directly receive data and send set points back to that device. On the network side, those systems are typically what integrates with the majority of the utilities software. So that's when you would have your DERMS technologies built into your other software that you use to schedule and things like that. And those don't connect directly with individual devices in the same way as the edge DERMS do. Instead, they connect with what's called aggregators, which are sort of separate sets of software that connect directly with the devices through those API calls and then send that information and telemetry back to the DERMS system itself.
Which means that some